Okay, hi everyone, welcome to lesson 3.2. This is an extension from lesson 3.1. If you haven't read or watched the video tutorial, I suggest you go do so because most of the code from 3.1 is implemented into this one. Okay, so in this lesson I will go over how we can use the data from Arduino to control interfaces or even GUIs sometimes, right? As you can see here, I have an interface with two boxes on here, and I'm going to use the potentiometer right here to rotate them. I also go over briefly how push and pop matrices works. That's to rotate and translate objects, and how interpolation works to smooth out animations. Okay, I'm going to give you guys a quick demo on how this works. So I have my potentiometer right here. If you remember from lesson 3.1, we sent this data from Arduino into a processing program, sorry. So if you look at the bottom here, we have all our values stated down here. I added two more values, mval and minter. Minter is our interpolation number. So first I'm just going to give this a quick demo. So here's the potentiometer. Watch as I turn it. Both these cubes will rotate accordingly. I'm going to do this. If you can tell, our x, y, and z values are also reading constantly. You can see our x is the one that's constantly changing as I rotate this, right? So x is the variable that is rotating amongst the y value for both these two cubes. If you can also tell, one cube is smoother than the other. That is called interpolation. So interpolation, basically this function down here, will be able to take our two numbers and calculate an approaching number to it. So it basically smooths out or adds more keyframes in between from point A to point B in order to have a smoother path from when it's rotating, right? So as you can see when I rotate it again, watch the minter numbers down here. So minter is the numbers that is manipulated by the interpolation function, and then mval is our original number. So mval is the number that's affecting the rectangle on the right, and minter is the interpolation number, which is affecting the cube on the left. So watch as I rotate it again. Pay attention to the minter values. So you see if I rotate it, let go of it, it's still calculating the point B number. So as you can see, mval, it already reached its end number, but minter took a while to calculate. So let me try this again. So you can see I let go of it and it's still calculating. See, on all those numbers from before, they're numbers that are in between from point A to point B. So if you know anything about animation, if you add more keyframes, more smoother something will be. It's like watching something that's 25 frames per second versus something that's 60 frames per second, because you're getting more data in between to see, basically, right? In this case, you're getting more values in between to have more steps the cube will take to rotate. So that's just a quick demo. Now I'm gonna go over the code. So we have the code from lesson 3.1 right here. Okay, so now we're just gonna add a few things. So first off, we did not initialize a screen size for our interface, right? So we basically just type in size and then brackets, and then we put our resolution. So it's 500 by, let's go 500 by 500, and then we're going to type in P3D. So that means our interface is going to be in a three-dimensional perspective. Okay, so usually when you're running processing applications, you're just using 2D perspective and a 2D environment. Now if we put P3D, we're now using a 3D environment. So this comes to play when you're using the X, Y, and Z axis. And we're also going to initialize our m value and m interpolate variables. So we go m value equals 0, m inter equals 0. Okay. Remember, these two variables will be the ones that will be rotating our objects. Okay, so if you don't remember, this is where we are reading our values from the serial monitor, or serial port, sorry. If you don't remember, this is where we're reading our values from the Arduino. This is our potentiometer. This is our pot value, right? Remember? So that's going to be the one changing our rotation. We're going to set it equal to our m value. So m value equals map x value 0 to 255 to 0 to 180. This is because we're going to rotate it 180 degrees. Okay, after we wrote m value, we're going to write, okay, after we wrote our m value, we're also going to map our m interpolation value equals interpolate m value, and then a constant number, 0.09, let's say. Okay, I forgot to declare the function. So this function will be declared at the bottom of void draw. Well, let's make some room here. So let's go float interpolate. We're using a float function because we're going to return a long decimal number. Float a, doesn't matter what these variables are, float b, and then float the amount we want to affect this by. So we're going to return a, b minus a, or a plus b minus a times the amount. Okay, so what this function basically is doing is taking two numbers from point A to point B and calculating a bunch of them in between, right? So when we have those bunch of numbers in between, we get a smooth transition from point A to point B. So for example, if we're going from 0 to 5, if we don't interpolate it, it goes right from 0 to 5 and makes a huge jump. But if we do use this function to interpolate, for example, it would go 0, 1, 2, 3, 4, then 5. With that 1, 2, 3, and 4, we have more data to rotate the object, for example, right? If we have that more data, we get a smoother transition from 0 to 5. Right? It's a bit more complicated because the decimal values are very, very big, or very, very large, sorry. Now let's draw our cubes, okay? So let's put some lights in here. We're just going to have lights like that. There we go, push matrix, and then pop matrix. So, in order to rotate something on its own origin, we want to write it in its own push and pop matrix. If we didn't do this, everything will translate and rotate along one origin, right? We don't want to do that. We want to be able to rotate objects on their own, right? Or even translate objects on their own, right? So it may sound a bit complicated at first, but once I write out the full code, you'll get better sense of it. Okay, let's write this on the right-hand side of the screen. Height divided by 2, and it's in the middle. And let's also move it a bit by the photoresistor. So remember, if you can't remember from 3.1, the Z value is the photoresistor. Translate, rotate, Y. Remember, we're rotating along the Y-axis. Okay, rotate Y. Radians, M value. Okay, now we have box 100. So that's just the color of our box. It's not white, it's It's not black, it's just a bit grayish. So this right here is rotating just our one box, right? I'm gonna take this and put that right there. Oops, sorry about that. So this means our box has no interpolation. That means there's no smoothing on it, right? So if I run it, takes a bit to load. If I run it, it's very choppy, right? Not too choppy, but we can make it smoother. So let's make the one that's smoother. Okay, one thing. Sorry, I was wrong about this. This is actually the size, not the color of the box. Okay, now let's continue on to the box with interpolation. With interpolation. So we're going to do it again. We're going to do the push matrix and pop matrix. Again, this is so that we don't want it to rotate and translate around the same origin. This means they will have their own origins to work on. Okay, translate width divided by 4. This is going to be on the left side. Height, and it also in the middle. Height divided by 2, and then z value once again. Okay, rotate y radians. In this case, we're doing the m interpolate value. And then that is it, sorry. Box 100. Okay. So let's run this. Well, let's see if we can get, oops. Sorry, I must have forgot one thing. Did I divide it by 2? Oops, sorry, I divided it by 2, not 4. That should be 4. There we go. So as you can see, when I ran this, you could see that. Let me try that again. See that? The box actually moved a bit. You saw it go from point A to point B once it started to run, right? So basically went from 0 to whatever this number is, 25, right? You can't see that with this one because it did it instantly, right? With this one, since it does have interpolation, you saw it rotate because it took more time to go from point A to point B because of all the steps it had to take, right? Because of all the other values in between. So I changed the amount that I'm going to interpolate by 0.01. Before it was 0.09. So the smaller it gets, the more animation I'm going to see. But in turn, it will become much, much slower. As you can see, if I start to rotate this, it's really, really slow. But it looks super, super smooth though, right? The values are still calculating, right? Look at all those calculations. It's almost at 0.45, right? Let me change it again. The original value is already there, so this one's already stopped moving, and this one's still calculating. All right, 2.6, 2.3, 2.4, there we go, yeah. And it's still going, right? But you cannot just see it. So yeah, this interpolation becomes very, very useful. It makes things much more smooth, and the animation looks so much better than something that's not smooth or filtered out, right? So yeah, this is it for 3.2. Interpolation is really, really useful, just like any type of sorting, data sorting, or any filtering for Arduino or processing, right? Just make things look a lot better. I hope you enjoyed. Thank you for listening, and goodbye.